All right, 14.2, investigating outliers. Here's the data set used to create the histogram and box plot from the warm-up. Use technology to find the mean, standard deviation, and 5-number summary. All right, so you can work along with me, but I will ask you to find it on your own, so please make sure you're either doing it on a calculator or doing it on on Desmos, like I showed in my video. You can watch the video from Friday's lesson if you want to learn how to do that. All right, so I'm going to go into my list, and I'm going to put these numbers in, and I'm going to do it, slowly, because these are tricky numbers to put in. So if I were you, I would start to do this as this video is watching, so you don't have to waste too much time when it pauses to ask you the question. You're already putting these values in as I am. All right, 1.7978. Sometimes I say stuff out loud to myself, 1.9702, because it makes, if I say it out loud, I don't make the mistake on the calculator. 1.9770. You'll notice there that if you put 0 at the end, it just won't include it. That's equivalent to 1.9770, so don't worry about that. 1.9890, again, I don't really need the 0 at the end. 2.1011, 2.1495, 2.2230, that's right, good. 2.5443, 2.7288, 2.7344, 2.8223, 2.8348, 3.2484, 3.3912, 3.5896, 4.0334, 4.1925, 4.3763, 4.5193, 4.6004, it's taking forever, 4.7081. This was on a computer, it would be much easier. 4.7528, 4.8398. And I really hope I didn't make a mistake. 5.2050, because there's no way I'm going back through this list again to check to see if I did or not. 5.3854, 5.5284. And I just noticed I missed one, so I'm glad I am doing this relatively slowly. 3854 is good. I forgot this right here. 5.4875, 5.5284, 5.5506, 6.6475, 9.8923. And so hopefully you never have to do that in your life, but I know there are 34 countries, so the fact that I'm at row 34, at least I know I didn't skip any, although I did catch the one I skipped. I could have very easily made a mistake typing these numbers in, so I hope they're right. I guess you guys will let me know if you guys are getting different numbers. All right, so now I'm just doing what I normally do. Stat, calc, one bar stat. And it's gonna give me everything I need. So I've got my mean, x bar is equal to 3.7259. Well, really, I guess I should round just to the third decimal place, the thousandths place. Because these represent thousands of people. So really, the mean is 3,726, because I rounded. And I guess I could put the squiggly ones to show that it's approximately that I rounded. Standard deviation, sigma, is equal to 1.827 about. Sorry, I keep forgetting to use a squiggly mark there. Okay, minimum. That's accurate. That minimum is definitely accurate because that's an exact value from the graph. So I can say the min is 1.0803, which is weird that they gave it like that. Like someone is getting, I guess, 30 cents, because if I move the decimal place, this would be 1,080 and 30 cents. So interesting that they're that specific, but I guess since you get charged cents on a medical bill. Q1 is equal to 2.1495. The median is 3.49. 904. And Q3 is 4.8398. All right, very, very possible you're getting different values. It's possible I made a mistake, maybe you made a mistake. It's all good. Maybe I'll make these multiple choice so at least you'll know if you made a mistake or not. All right, and I'll do it again after to make sure I got everything right for you guys. Okay, that is everything I need. The maximum value in the data set represents the spending for the United States. Of course, the United States spend the most on healthcare. Should the per capita health spending for the United States be considered an outlier? Explain your reasoning. Well, we know how to define that, right? An outlier, based on what we learned in the previous page, is going to be Q3 plus IQR times 1.5. So let's calculate that. Q3 is 4.8398 plus, well, actually, I mean, all this data, I mean, this is the height, right? This is the US here. This is exactly the same as what we just did. So I know it's going to work out, but I want to actually use the calculations using the actual numbers, not just estimations, because we just estimated the last one. So this is 4.8398 minus 2.1495, all of that times 1.5. Now I'm going to put all that into my calculator at once. 4.8398. So as you can see there, I really hope I'm not making mistakes here, because there are just so many decimal places. I feel like it's so easy to make a mistake with this. But I guess they want you to be careful. All right, and we get 8.87525, which seems pretty reasonable based on what we did before. And so that would mean that this value is above 8.8, right? 9.8. So it's definitely going to be an outlier. Should it be considered an outlier? Yes. It is by definition. All right, 3. Although outliers should not be removed without considering their cause, it is important to see how influential outliers can be for various statistics. Remove the value for the United States from the data set. So if you're on Desmos, just delete the row in the table. If you have a graphing calculator, just go to the last row and delete the value for the US. And now they want the same values. The same 5-number summary, I mean. Obviously it's going to be a little bit different now. So this 5-number summary, we're getting X bar, let's go to 3.5391. So that went a little bit too far decimal wise, but it's fine. Standard deviation is 1.5006, or really 7, I guess if I round. Let's go down to the min. Min is 1.0803, that shouldn't change. Q1 might change a little bit. 2.1253. Median is 3.3912. Q3 is 4.7963. And our max is different now. Our max is going to be the 6.6. All right. So, great. How do these mean, standard deviation, median, interquartile range of the data set with the outlier removed compare to the same summary statistics of the original data set? All right, so let's compare them. Take a look at those, and in your own words, what happens to our original data set when we remove that outlier? All right, well, one thing you notice is that the mean is lowered. So the United States was really bringing up, it was skewed, right? That distribution was skewed. The United States brought the amount of spending up for the entire world, almost, it seems like. The minimum stays the same. The median goes down a little bit, which is a big deal. If the median is affected by skew, then it's pretty significant, right? Usually we say the median is sort of able to go past that, but here is affected by it. Q1 went down slightly. Q3 went down slightly, and our max went down by 3,000. And standard deviation is really what stands out to me the most, though. The fact that this standard deviation is so much less means that my data is closer together now, which is more reliable. The larger the standard deviation, the more variance and less reliable you can say the mean and median are. The lower your standard deviation is, the closer your data is together, the better you can feel about using mean and median as a predictor of what might happen. All right, that is all for 14.2.